How do you find segment lengths in and around circles? This is for section 12-4 out of your textbooks, 12-4, and this should be the second video for your notes. The first one was how do you find angle measurements in and around circles, and this one's for segment lengths. Here's a reminder of how your notes should be set up to take notes from this video. We already did video title number 1. This is video title number 2, and there's no 3. Don't forget to review your notes before you write your summary, which should be at least 3 sentences in length. Okay, here is our segment length theorems from chapter 12-4. Go ahead and copy down everything you see here, and then when you're ready to follow along with my voice, then go ahead and resume the video. So this is theorem 12-12 out of the textbook. It's normally not called theorem 12-12, but just for our textbook's sake, it is called that. For a given point in a circle, the product of the lengths of the two segments from the point to the circle is consistent along any line through the point and circle. That sounds very confusing, so you would have to break that down. For a given point and circle, so here's a given point in a circle, the product of the lengths of the two segments, so product of the lengths of the two segments from the point to the circle is consistent along any line through the point and the circle. So in other words, these are the formulas that you need to have memorized. If we look on the inside of a circle and the segment lengths are only on the inside of the circle, then we will do part times part equals part times part. So A times B equals D multiplied by C. That's for if it's all inside. If it's on the outside of the circle, like for these two examples, remember this T looks like it's a tangent line to that circle. If this happens, we do outside part times whole. So the outside part, which would be X plus W, and then we multiply it by the whole, which is out here W. And same here, it's going to be Y plus Z times the whole outside here, which is Y. And here we do Y plus Z and multiply it by Y, the outside. And this is going to equal just this T squared. We're just going to square that T. So let's practice these 3 examples. Okay, we're going to practice 4 examples to make sure we understand the theorem. And remember, those are they gave you formulas to memorize. So let's first look at example 1 and example 2. Go ahead and write down the examples, copy down the pictures, and then see which theorem you think you can use and try to solve for the unknown variables. You're capable of doing that, especially since I just gave you the theorem. So let's practice them. Once you're ready to follow along and check, then go ahead and resume the video. But I will give you a hint. Both of these examples represent the second part of the theorem. Okay, here are the answers. Let's go ahead and take a look at the work. So this is the second part of the theorem, which means that we would add these two together and multiply it by the outside. And then we would set that equal to adding these two together and then multiplying it by the outside of 7. Distribute the 7, and then you add and multiply by 6. Then you solve for y, and y would give 5. Then for number 2, and notice it says round your answer to the nearest tenth. For number 2, this is still the second part of the theorem. So I'm going to add these 2 and multiply it by the outside 8, which is here. And then this is just going to be z squared. So then I solve the right-hand side and get 192. Square root both sides, and z equals 13.9. Okay, bring any questions you have to class. Let's practice 2 more examples for the theorems we just learned. Okay, here are 2 last examples for us to practice on the theorems that we just learned. Let's go ahead, and these are going to be examples 3 and example 4. Think about which theorem would apply to these circles, and then go ahead and practice and see if you can solve for the unknown variables. Once you've practiced and you tried them and you have your answer, press resume and you will see the answers revealed, and we'll discuss them together. Okay, here is the work for both examples. Let's look at example 3. Remember, we add these 2 together, multiply it by the outside equals to adding these 2 together and multiplying it by the outside. Then you distribute here, and then you simplify here. Then you solve for x, and x gives you 13.8. For number 4, this is the example for the first theorem. Okay, this is the first theorem here, which says that we're going to multiply 3 and 7 and set that equal to 6.5 times m. So we set that up here, and then we solve for m, and m equals 3.2. So notice you'll need to use your calculator, And you'll have to remember which theorem to apply when and what the theorem is telling you to do in terms of setting up your equations. So this is where the algebra comes in handy. Bring any questions you have and make sure to review all 4 examples. The question for the video is, how do you find segment lengths in and around circles? We just discussed the theorem used to figure out segment lengths in and around circles, and there's 3 parts to the theorem. Then we've practiced 4 examples where we practiced all 3 parts of the theorem. Now that you've had the practice and the experience, I encourage you to look in your textbook and also review. And then once you've done that, answer this question as your summary. How do you find segment lengths in and around circles?